Hey everyone, so welcome to this video, and in this video we are going to discuss about BFS, right? So BFS is nothing but breadth first search. Okay, so in the previous videos we have discussed about in-order traversal, pre-order traversal and post-order traversal. So these traversals were actually DFS traversal, DFS. So DFS is nothing but depth first search. Okay, so in case of BFS we traverse the tree through level by level. Okay, and this is called level order traversal. So BFS and level order traversal both are same thing, right? So if I talk about this tree, it has three levels. This is level 1, this is level number 2, and this is level 3. So we'll traverse these three through level by level. So this is how we'll traverse this tree. So in the first level we have only one element, so 10 will print 10 here. After that we need to traverse level number 2, that is 6 and 18. So 6 and 18 will get printed, and after that level 3, that is we have around 4 elements in level number 3. So 4, 8, 15 and 21. Okay, so this is how we print elements in BFS. Okay, and if you're doing BFS traversal on binary tree, then you have to make use of one more data structure, which is queue. Okay, so queue is nothing but it's a kind of data structure. It's like an array, and it is based on the principle of FIFO. FIFO is first in first out. Okay, so let's say if I insert 3 elements inside this queue, let's say 1, then 4 and 6. Okay, and this is we are inserting these elements in a sequential order. That is, the first one will get inserted, then 4 and then 6. So if I pop out these elements from this queue, so first element that we can pop out is 1, after that 4 and 6. Okay, so this is how FIFO works. Okay, so the element which is inserted first will get popped out first. Okay, so this is about how a queue works. Okay, let's move on to BFS and see what are the steps that we need to follow in BFS, right? Okay, so what I'll do is I'll write all the steps here. So the first step that we need to do is we need to push the root node. Okay, so we just need to push the root node inside the queue. After that we need to create a while loop. I'm not writing the condition here. Okay, I'll write it later. Now inside this while loop we need to execute 4 steps. Okay, so the first step here is pop. We just need to pop out the element and store it in a variable. So I'm writing it in short here, like pop and store. Okay, after that we need to print out the root data. So print node data. Then the third step is to push the left child. Okay, push left child, and the fourth one is to push right child. Okay, so these are the steps that we need to follow in case of BFS, right? And if I talk about the condition of while loop, so here we have to write while queue is not empty. So we need to execute this while loop until the queue becomes empty. Okay, so these are the steps that we need to follow for BFS. So the first step is to push the root node, and after that we need to follow all these 4 steps inside this while loop. Okay, so let's execute all these steps on this tree, right? So we'll pass root node as a parameter inside a BFS function. Okay, so the first step is to push the root. So I'm writing 10 here. Okay, then we'll come inside this while loop because the condition got satisfied while queue is not empty. So here queue is not empty, so we'll come inside this while loop, okay, and we'll execute all these 4 steps. So the first step is to pop and store. So we will pop 10, and store it in a variable. Second is to print node data. So I'm writing 10 here, right? Third step is to push the left child. So I'm pushing 6, and fourth one is to push its right child, which is 18. So 18 is also pushed into the queue. Now we will go back to the starting point of while loop because queue is not empty, okay, and again we have to run all these 4 steps. So the first step is to pop, so 6 will get popped up and we'll print 6. Second is to push left and right child of 6, that is 4 and 8. So we'll push 4 and 8 inside the queue. Third step, second, third steps are executed, okay. Now we'll go back to the starting point of while loop and execute all the steps. So first step is to pop, so 18 will get popped out and we'll write 18 here. Second is to push left and right child of 18, so 15 and 21, okay. So for 18 all these 4 steps are completed. Now again we are here. First step is to pop and store, so 4 will get popped up and we'll print 4 here. Second is to push the left and right child, so we don't have any left and right child of 4, it is null actually, so we'll not execute anything, okay. Now in case of 8, again we just have to push its left and right child, okay. So here we don't have any child, this is null, okay. So 8 will get popped up, and similar case is for 15 and 21. We don't have any child for these 2 nodes, okay. So 15 will get popped up and for 21 also, right. So this is how we do BFS traversal in binary tree, okay. So let's see the code, right. Okay, so here I have created the same tree, this tree, okay. So what I'll do, I'll create a function for BFS, okay. So void BFS, let me just, okay. So void BFS and we'll pass root node as a parameter. Okay, so the first step is to push the root node inside the queue. So we need to create a queue first, queue of node, and we'll push root inside this queue, okay. After that while loop, and the condition is queue is not empty, okay. And here the first step is to pop out the element and store it in a variable, right. So I'll create a variable temp and queue.front. So this method will give the top element or the first element inside the queue, okay. And after that we need to just pop out that element, right. And the third step is to check the left child. So we'll check if temp of left is available. If it is available, we'll push that child, temp of left. And one more thing is that we need to print the temp of data, okay. So this is actually step number 2. So now similar case is of right child. So if temp of right is available, we will push that node inside the queue, okay. So these are the steps for BFS traversal. Now if I run this code, sorry, we just need to call this function, and this is not print, this is cout. Okay, so you can see the output, which is 10 6 18 4 8 15 21. 10 6 18 4 8 15 21. Okay, and one more thing, let's say if I pass null here, okay, so we can write the base condition. If root is null, then we'll simply return to the main function. Okay, so this is the base condition for that. Okay, so this is how we do the BFS traversal in binary tree. So that's it for this video. Thank you.